I have another video that shows you all the parts of a pyramid. You need to watch that one first before you kind of check this guy out. But now that we have seen that, let's draw some of these guys. So let's do a right square pyramid. So what would be the shape of the base of a right square pyramid? Cool. We'll use shape 22, and we'll give ourselves rooms to draw the top of it. We'll draw the front part solid and the back part dashed. All right, so shape 22. And for you out there in video land, if I'm going too fast, just pause the video. Here's what we'll do, though. You see the vertex of this guy? We got to go find him next. Here's an easy, sorry, I did that. Here's an easy way to do that. Just kind of go to, like, put your pencil over the center of this base and just slide up a little bit. And put yourself a dot there. All right, so roughly the center of that base, just slide straight up. Because he was a right pyramid, we're going directly above the center of that bad boy. Then take your straight edge and connect those three dudes solid and the one in the back dashed, because you kind of have to look through the object to see him. Then they say, is he right or oblique? Right, so let's put a dot right here on the center of the base and use your straight edge to draw in this height that goes straight down. I like to put him dashed as well, and then a little right angle box in there. So somewhere in the center of the base, I know you just kind of got to guess. It's not going to be perfect, you know, but it's a right square pyramid. He is also a surface, so shade him in or not shade him in. Not shade him in. That means he is hollow on the inside. Just like this dude, I could take him over to the sink and fill him up with water. There's a little hole there. I could totally do that. It's empty on the inside. He is a surface. How about an oblique cone surface? What is the shape of the base of a cone? Circle. So use the 3D circles. It's either 27 or 28. Do I have the right numbers on those? 27 or 28. Just pick one of them. Doesn't matter which one. Shape 27 or shape 28. Either one is good. Front part solid, back part dashed. And then I go put the center of the base in there as well. Just put a little dot in there. And since he's oblique, I'm going to go up and over just a little bit. How far over? Not a lot, you know, but do not go directly above those. You're not going to have another circle on top. That would make a cylinder, right? Only one of them. Remember, that's what gets confusing about these guys. That's why I like to write the formulas down also. One base area or two base areas. One base area or two base areas. So this guy has just got one circle on the bottom. He is oblique. And you tell me, shade him in or not shade him in when he says surface? Not. Why don't you pause the video and try number 3 to draw a right hexagonal pyramid solid. So there's my hexagon. Since he is right, I'm going to go to the center of the base and slide straight up and connect with a straight edge from all 6 of these vertices. Boom, 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 boom. And the back 2 are dashed. Then we need to make him right, like mine's still not finished, so make sure you drop a height in. And then I need to decide if I should shade him in or not shade him in. What would you like, shade him in or not shade him in? Shade him in. Shade him in. Here's what I want to do. I want to go back to number 1 and draw some extra thing in there. So let's do this. Would you take your straight edge, I'm not going to do it dashed either, and draw that in right there. That blue dude right there. And put a right angle box down here. And that blue guy is not the height. He is the slant height. So we'll put like a cursive L by him. Cursive L does stand for length in some situations. In a pyramid or a cone, it will stand for the slant height. So good question there. And I put an H by that guy. We're going to need that slant height for a lot of things. The slant height is in all 4 spots. I should use a straight edge, but it's over here, it's over there, it's on the back side. It's the easiest to see on that side that we drew it on because it's like we can see the face of that so much easier. So that's where I like to draw that guy. Cool. So let's check this guy out. This is a right cone at the right. Name the height. Question for you to make it fast. Is it the orange guy, or is it the green guy, or is it the pink guy? Which one of those is the height? Orange one. He is a segment, so let's call him segment AB. Isn't that orange one like segment AB? Name the vertex. That's like the pointy part at the top. So what would that be? A, capital letter, because he's a point. And did you notice when I highlighted those 3 dudes right there, a good old shape showed up. Not the cone at all, but what shape did you see thanks to that right angle box? We have a right triangle in there. So they say if the slant height is 5 inches, that's going to go on the green guy right there. And oh God, the diameter of the base is 6 inches. That pink thing is not the diameter. What's the pink thing right there? It's the radius. So if the whole diameter is 6, how do you feel that that should be half as much, which is 3? Are we cool with that? And they say, what is the height? Well, since they don't tell me, I'll call him H. And you're lucky that I have prepared you to not have to do the Pythagorean theorem on this one if you have been trained properly. What is the most popular right triangle around? 3, 4, 5. 5 better be the hypotenuse, though. Is the 5 across from the 90 in that situation? So the height is 4 inches. If you didn't know that, you'd have to use the Pythagorean theorem, which we'll do this chapter. We'll have to do that on a bunch of right triangles. But 3, 4, 5 is the most popular. Who is the second most popular? Not 3, 4, 5, but 6, 8, 10. You just double all those guys. And then the other one is 5, 12. You might want to write those down if you have been struggling with those because they're going to show up a bunch. 3, 4, 5, 6, 8, 10, and 5, 12, 13. The long guy has to be the hypotenuse, though, so that's 5, 10, and 13. Right, so 3 most popular guys around. You see them all over the ACT, probably state assessment as well. Right, so it's there to save us time to memorize those. So check this guy out. The right cone has a radius of 8 inches. Let's put that in the picture. And a height of 15. Find the following. Holy cow, what does that thing say? Say slant height. What does that thing say? Cool, we'll put him in the picture. And here's where we got to do the Pythagorean theorem because we have that right triangle. So we'll show that work. Remember the hypotenuse goes all by himself. So 8 squared plus 15 squared equals L squared. Make sure your L is cursive because if it was like straight up and down, it looks too much like a 1. Right? So we'll make it that way. And go ahead and punch those 2 guys in if you need to. If you haven't memorized, good for you. But if you need to punch them in, punch those guys in. And 15 squared, how much, baby? 225. And then we'll add those together. So 64 plus 225. I got 289 equals L squared. But they didn't want me to find L squared. They want me to find L. So how do I get rid of that square? Square root. Let's see if that comes out nice. So the square root of 289. If it comes out to be a whole number, we'll use it. If not, we'll keep it the square root of 289. Does it come out to be a whole number? Yes. So that means 289 is a perfect square. We usually just have you memorize the first 15 of them, but they go on forever. So the slant height is 17. Let's throw a label on that. These guys were in inches, so wouldn't that also be in inches? Any questions on how I found the slant height with the Pythagorean theorem? Now let's find that lateral area. Go to the formula sheet. This is a cone, right? So lateral area formula, messy looking. I got 1/2 times 2 pi r times L. Correct? Is that what yours says as well? If you look it up in any math textbook, it will never say that. This is the Pfannenstiel version of the formula because here's what happens. What's 1/2 times 2? Half of 2, baby. 1. This times 2 and divided by 2 will always cancel each other out. Every math textbook will say the lateral area formula is pi RL, but I hate it because to me, look back to like prism, my bad, pyramid, which one am I trying to do? Pyramid's formula. 1/2 times P times L. What does P stand for again? Perimeter of what? The base. Hey, check it out. Perimeter of the base means just going around it. Isn't that like on a circle, the circumference of it? This is the same formula. 1/2 times the perimeter of the base, which is called the circumference, times the slant height. So we'll write that guy down and then cross out the 1/2 and the 2 every time. And all I need to know is the radius. So pi is going to come down. How much is our radius? 8. So you get squared or not? Not in this formula. And our slant height is 17. So what we got to do to clean this up is just hold on to the pi, multiply everything else together. Take the 8 times the 17. How much? 136. And just don't you forget about that pi. It is 136 pi. And then we'll punch that in our calculator to approximate it as well. So 136 times pi, like so. And it'll be nasty, boy. Nice and nasty. Let's round that to 1 decimal place. Would you like a 0.2 or a 0.3 on that one when there's a 5 to the right of it? 0.3. So about 427.3. And throw a label on that puppy. Would he be in inches, inches squared, or inches cubed? Inches squared. All area is in square inches. So that was the lateral area. It's a weird little formula, but the 1/2 and the 2 will always cancel each other out. It's 1/2 perimeter of the base times the slant height. Surface area? Oh, look at that formula and tell me why it's got to be different than a prism's. You can write it down first, and then what's different about him? Lateral area. So, sorry, I forgot to unpause it. To find the surface area, you got to find the base area. Radius squared is 8 squared is 64, so I had a base area of 64 pi, and I had to add that to 136 pi and get 200 pi, which is approximately that, inches squared. Next shape right here is a pyramid, right? He is a square pyramid. Let's put the info in there. Square pyramid has a height of 12. This is the best spot to put the 12 in all the years that I've done it. A lot of students sometimes put the 12 over here. And it gets confusing because there's some questions that use that dude right there, which is a lateral edge, and that's not the height. So I like to put the 12 right here in this mess. And it's got a base edge. Oh my God. Base edge. That would be this dude right here. This is a base edge of 10 inches. Well, here's a little fact. Here's what happens. We need that cool right triangle. So use your straight edge, because the straighter you make this, the easier it is to understand. But we're going to draw this little guy in right here. And that goes from the center of the base to the base edge. And since this base edge is 10 and it's a square, that's going to be half as much, which is 5. So it's hard to see that stuff. But that is right there in the center of the base, and I'm going to go over here. The reason why is because the first question asked me to find this awesome green segment, which is known as what? What is that green segment called? The slant height. Use a straight edge to draw that guy in. And as difficult that is for a lot of people to see, I think we're getting to the point to where we're understanding. We keep getting right triangles to show up in all of these pictures. And I have a leg of 5 and a leg of 12, and they are asking me to find that slant height, which is the hypotenuse of this. 5, 12, what? 13, baby. That is the third most popular guy around, so 13 inches. That is the hypotenuse of this dude. Try to find the lateral area. First, start with the formula. Lateral area equals. Find him on your yellow card. See if you know what those letters mean. Sub in and see what you got. So the perimeter of the base is 40. It's 10 plus 10 plus 10 plus 10. You're just adding them all up. And then the slant height is 13. So you can punch all those in. I got 260. Is that what y'all got? Inches squared. And then let's see if you can try the surface area without me walking you through it. Start with a formula and sub in the things that you know. Perimeter of the base means add up all the sides. 10 plus 10 plus 10 plus 10. Base area. So I know my lateral area is 260. And then to find the base area, my brain has to go, what shape is the base? It's a square. How do I find area of a square? Side squared, you know. So that's one of those shapes. I don't care if you go off to the side and show work on, right? It's just a square. It's side squared, or also length times width. 360 square inches. Pretty boring. When we put some story problems to it, it'll make a lot more sense, but it's got to kind of do the basics before we put some story problems to it. Are we cool with the right triangles in the shape? They're hard to see sometimes, like where they're at. Right? Perimeter of the base. Cool. We're going to cross out the surface area part of this bad boy and only do the lateral area. Here's a tough one to see, but they do tell you what shape it is. What shape is it? It's more than a triangular pyramid. It is a what? Regular. Time machine. Regular means all sides the same, all angles the same, in that base. So like the base is a regular triangle. Regular triangle. So somewhere I have it, that's this guy. This is regular. All sides the same, all angles the same. He also has a fancy name of equilateral triangle. Right? So it's all good there. So do you just want the lateral area? Start with the formula, and let's see what you got. The points out of that. So this is a pyramid, and they want its lateral area. It's 1/2 times the perimeter of the base times what? Does that L mean? Slant height. Perimeter of the base means you have all of the sides, so you can add them up. That's why they told you this triangle was regular. Aren't all of them 7? Right? So 7 plus 7 plus 7 is 21. And then here's the question. Who the heck is this guy? Is he the height or is he the slant height? Because it can be hard to see that. What do you think? Height or slant height? Because that goes to the midpoint of the base edge, right? That is the slant height, yes. So they gave us everything we needed, right? That was nice. I like that one. So we'll punch that in. It's cool if you get a decimal. So 21 times 12. And then divided by 2 or times that. I got 126. Did you get 126 back as well? Sometimes you will get decimals back. That's okay. And then the M is meters, so 126 meters squared for that. I don't want to find the surface area. I'll skip that. Lateral area is good enough for me. We're okay with that? All right. Shape recognition, get you a formula for the first thing they're asking. And we'll do the rest together. Honestly, I'm still recording. It's honestly harder than you think because there's another shape we still have to learn. You already know what it is. He's a sphere, right? But you put spheres, pyramids, cones, prisms, and cylinders all on one test. It's easy to get confused. So phase 1, what shape do I have? What's the formula I need? This is the guy where those will cancel each other out. So we'll say peace out to those. I need the radius and the slant height. Do I have the radius? Yes. Do I have the slant height? Nope. Ooh, 4, 5. Is that slant height 3? Discuss that with your group. Is that a 3 because of the 3, 4, 5 being the most popular right triangle around? Yes or no? Very good that it is not 3 because 5 has to be the hypotenuse. So we're going to call him L, and we got to go off to the side and do the Pythagorean theorem to figure that out. So 4 squared plus 5 squared will equal L squared. Remember, the hypotenuse is the guy that goes all by himself. What's 4 squared? 16. And 5 squared is 25. I don't know why I wrote 21 down, but he's 25. And that'll be L squared. And then we'll add those together and get a number that's not my favorite number in the world. What is 16 plus 25? 41, right? It's not a horrible number, but you realize I have to square root that guy. And I don't think that's going to come out nice, right? So square root of 41, we're not going to write that down. And we're not going to round him off either. We're going to leave him the square root of 41. So the slant height is the square root of 41. And I know, like, some of the other teachers think I'm crazy for keeping everything so exact. I'm the guy that's trying to bring this into the real world with the construction-y things that people have to do with it. And the more you round stuff off, the worse your project is going to turn out. Like, we have to kind of keep things exact. So I'm trying to train you that way. So those canceled. Let's go back to our formula and look at this mess that we got. Pi times the radius. How much is the radius? 4 times the slant height of the square root of 41. And this is the one case where I think putting an answer with a pi with it is silly. Like, we just got too much craziness. We got a pi, we got a radical, and we got a whole number. We have kept it as exact as we can to this point. Would you agree? We haven't rounded anything off. To me, we'll just go to the blank and put the approximate answer instead, right? So we take the pi times the 4 times the square root of 41 using the exact values from our calculator. Pi times 4 times the square root of 41. Like you see, sorry, thought I had it blown up. But none of that has been rounded off, right? Those are all the exact values. And just hit equals. And also, don't get in a habit of clearing your calculator out. Keep that number there for a reason. But did you all get that guy right there? We will round him. About 80.4 or 80.5. What would you like? About 80.5. But keep him in your calculator because we're going to use him in a second. 80.5 square meters. Because obviously the next question is find the surface area, and don't we have to like use the lateral area and add one base area to it? So here's what we'll do. We'll do the surface area equals lateral area plus one base area. Going off to the side to find that base area, pi r squared. Find that base area, but leave a pi with him. Find that base area. You're welcome to write 4 squared down there, but I personally think it's just faster to go straight to the 16. Right? Did you get 16 pi? And here's how I'll let us cheat this. Thank you for writing the formula down. Thank you for showing the work for base area. Would you believe I just need to add the lateral area plus my base area? And do I already have the lateral area sitting right there in my calculator for me? So I'm not going to round him off. I am just going to hit plus 16 pi. Plus 16 pi. You see how like I used the previous answer button? Let me know if you need help punching that in. But the messy guys, we're going to just leave that dude sit in our calculator and hit equals. And did you get about 130.7 back on that guy? So weird mess with radicals and pi's. It just looks weird to write all that stuff down. We'll do as far as we can, about 130.7. Is that what I said? And then the label on it is meters squared. Yeah. Here's one application problem for us. I'll let you read it and see what you think. After we've read it, we ask ourselves, what shape is it? Pyramid, square pyramid, yes. And then, like, what do they want? Well, that's the interesting part. I kind of pulled something up. It's pretty rare to see buildings that are square pyramids, but they do exist. If you ever go to Las Vegas, here's one of the most famous casinos around called the Luxor. It is a giant square pyramid, and everything is made of glass, right? Those are all windows on that bad boy. And the people who have to clean those windows work 24/7, 365. Man, they are cleaning those windows all the time. I bet you these days they probably got some robots cleaning those windows, but back in the day it used to be quite a job to clean those windows. But this isn't the Luxor, this is a greenhouse. Here's what I want to know. What concept should we find if they ask how many square feet, we'll come back to that in a second, of glass are needed for this greenhouse? Lateral area, surface area, or volume? Discuss with your table. What do we need? Lateral area, surface area, or volume? Which one did you throw out first out of lateral area, surface area? Which one is like, it's not this. It's not volume. You're not going to fill the greenhouse up with glass, right? It's either the lateral area or the surface area. So you tell me, what's the only difference formula-wise between the lateral area and the surface area? What does the surface area have that the lateral area does not have? The base, right? So here's the question. When we make this greenhouse, should this be glass? And this, and this, and this. What about this? I don't think this needs to be glass. Would you agree with that? So what do we need to find? Lateral area, surface area, or volume? Lateral area, because the bottom is not going to be glass. But there is a small problem here. They want it in square feet. And what are our dimensions in? Yards. Here's my best advice for you. Let's change those yards into feet before we get started. How many feet are in a yard again? 3. So since this is a yard, I'm going to go to a smaller unit. Isn't a foot smaller than a yard? I need to make this guy get bigger, so I will have to multiply by 3. So this would be 90 feet. And this would be 18 times 3. You can punch that in. 54, is that right? Maybe I'm brain farted. Is that right, 54? 54 feet. Cool. So changing them into feet first. Let's do lateral area of this pyramid. Start with that formula. This is your process. What shape and what formula? And no. Do we have those ingredients? We can find the base pretty easily because it's a square pyramid. Do we have the slant heights? We do not. Please use your straight edge to draw him in. The more accurate you make your pictures, the easier it's going to be to find that guy. And I'll bet you realize we probably need to draw that little dude in as well so we can have our cool right triangle that we got going on for us. So if you have not figured that out, here's your warning. You're going to need that right triangle a lot. And they try to trick us by putting this 90 feet thing over here. I like him right here as well. I don't care if you put it down there or not. But to me, it makes it easier to figure out how long that is. Because this is a square pyramid, and the whole bottom guy is 90 feet across. I got to go from the center to that. So what do you do to that 90? Divide by 2, and he is 45 feet. All right, so we got a right triangle with sides of 45 and 54. So we'll go do the Pythagorean theorem with some big old numbers to find that slant height. And do each one separately. I kind of like doing that. It's easier for me to grade if you figure out like what 45 squared is first. And write them down. 20, 25. And 54 squared second. That way, if you happen to hit a wrong button, I at least can see you knew what you were trying to do. We just hit a wrong button somewhere. Find that slant height. So the slant height is still going to be a nasty little radical here. And perimeter of the base is 90 plus 90 plus 90 plus 90. All right. Tree 60. And then we'll punch all that in. You can do 1/2 or 0.5 if you wanted to, times 360 times the square root of 4941. And I got this. And that's a pretty big greenhouse right there. Do they tell us how to round it in the problem also? That's one thing. We do a really good job by the time it's tested, getting the right shape, getting the right formula, getting the right numbers, and then it's like, oh crap, we rounded it differently than what they wanted. Do they tell us how to round it? They don't. So we'll say it's about that big old number of 12,652.6. Realistically, the whole reason that I asked that is it probably makes more sense to round to a whole number, you know? It's like 12,653 square feet approximately, but we'll deal with that another day. And then there's one last concept. This will go much faster than you think. Look at that weird word down there. It's called truncated. So check this guy out. If you're in video land, you won't be able to see this. I have a cool model that you can see the next time you're in class. So first thing we do, we'll do shape 22. And these are pretty hard to draw if you try them another way. I've watched over 20 years of students trying to draw this. I was like, let me show you a better way to draw this guy. So the first thing I want you to do is just draw a square pyramid. So we'll go straight above the top. If it doesn't say right, let's try to make it look right. So we'll just draw the square pyramid where these guys go boom. Let's use red to here, to here, to here, and then that back one is dashed. And here's why it's hard to do if you try to just draw it by itself. We've got to cut the top off of that, dude. And you have to do it parallel, right? So I don't want to work too fast ahead of you. I'll make sure you get that done first. And because I'm being so specific with this, I will take off points when you draw truncated guys if they look really, really bad. It's okay if they look kind of bad, but if you like totally do this a different way, I'll take off points for that. Check this guy out. See this edge right here? Watch me first. I'm going to use my straight edge, and I'm going to just go up to a certain height. I'm going to use solid instead of dash, and I'm going to draw another segment somewhere up here that is parallel. See, that's not parallel to it. Are you with me on that? That's totally not parallel to it. I want to draw another segment parallel to that. Use your straight edge. Do that move right there. Chord. The next move is wherever this little spot is right here, where it touched that lateral edge, you need to draw another guy that's parallel to this orange guy right here with your straight edge. So just like right there. And that's the hard one to do. If you're off a little bit, that's no big deal. But try to make this guy right here parallel to this. And then here's the secret to make it be successful. We're going to cut the top off now. And we'll use the other side of our pencil to do that. Let's erase the top, like so. Erase. Leave those other edges. Erase that guy. If you need me to do that again, I can. I can back it up. All right, but I just erased the top. And then I got to go draw two more edges. They're all solid, so I'm going to try to make one parallel to this blue guy right here. It's hard to do that one. He's kind of tough, but just kind of like this and then kind of like that. And if you mess that up a little bit, you can erase and try again. Like even mine right there is not perfect, you know, but it's pretty close. Pretty close. That is a truncated square pyramid. The two bases are the same shape, but they are not the same size. So they're similar to each other. And we'll do number 10, and then we'll talk about these here in a second. What would be a truncated right cone? Like what shape are the bases? Same size or different sizes? If you truncate it, will they be the same size or different size? Different? Boy, are you in luck. Does your geometer have two 3D circles on it, right on top of each other? Here's what I think would be best. If you turn your geometer around 180 degrees to where you could, I don't have a cool little drawing done, but if you draw the bigger one on bottom, and then just leave your geometer right there and draw the smaller one on top. Just draw those two right next to each other. But turning your geometer around puts the bigger one on the bottom and the smaller one on top. Mine's all nasty, boy. But there's no excuse to draw a truncated right cone incorrectly. So we'll put our straight edge and use these guys. Booyah. Booyah. And because it said the word right in there, we'll go to the center of the bases and draw ourselves a height and put a right angle box. Those are pretty cute. And here's where most of the test questions will come about truncated shapes, is name some realistic objects that are actually truncated. Let's start with this. I'll give you one to get you started with. Have you ever eaten this candy in your life? Rolos. Do you know what I'm talking about? Does the Rolo look a lot like this? If you haven't eaten, I totally understand. Come up with 2 more things at your table of what a truncated right cone could possibly be.